All right, what's good, y'all? Link here. I'm going back to the daily question for day 11. It took me a while to understand the solution. So what I did pretty much was I tried to understand the theoretical part, and then I tried to code myself. So I did that yesterday, and I want to try to do this question again today. That's a pretty good tip, though. So when you can't do a question, you try to understand, try to implement by yourself, and then the next day you try again. Okay, so let's see. I have a couple notes here, so I'm going to use that. So the idea here is kind of use Cadence algorithm. So pretty much the idea is that, let's say we have like an array that has like a couple numbers. If we want to find, let's say we want to find the maximum subarray sum. Let's say this part is the maximum subarray sum. So how do we find the subarray sum of this part? It's pretty much uh, the whole thing up to here minus the previous one, right? So not this one, but like here. So let me draw this better. So let's say we have an array, which is the y one, and then we want to find the subarray of this part, right? The subarray part, the subarray. Oh, let me go a little behind here. Okay, so we still have a couple elements in here. If you want to find the subarray sum of that part, it's pretty much we kind of like accumulate the sum as we iterate through the array. And then we have like a specific subarray before here, right? So let's say this is the size k because we need to be at this size k. Let's use k for example. So the subarray sum of this part right here is just use a green one. Is this whole thing, right? Minus this part, which is the previous sum. So let me do right here, right? So if we accumulate the sum, if we just take this part, this is gonna contain the max subarray sum of this whole thing. But if we take out this part, the yellow part, we're only left with the subarray from here to here, right? So this is kind of the idea of Cadence algorithm, and we're going to use this to calculate the frequency. So let's see. The idea here is that we kind of like want to start with size k because we gotta have a subarray of size at least k. We're gonna move this window forward, and as we move forward, we're gonna calculate the frequencies that we saw in the past. But that's the tricky part here is like, uh, let's say we have, go to Y again. Let's say we have this whole thing, and then let's again let's say we want the maximum frequency between here, if here and here. This is subarray right here. Uh, let's see. Mm, okay, yeah. So how do we find the maximum frequency for this range? We just take this whole thing, like so, up to here, like this part, and we subtract this part, right? So this contains for the whole thing, the red, the most right part contains the whole thing, and then this right most part for the yellow contains the left from 0 up to here. And if we take this out, we only have this subarray. But the thing is, like, let's say we have, let's say this part is like frequency of ones. Let's say it's odd, right? Let's say we have an odd amount of ones and then an even amount of twos. We're going to do frequency of 1 minus frequency of 2. So let's say we have this part. I'm going to use, let's say, A and B to denominate the current element that we're looking at. So let's say A is equal to 1, and then B is equal to 2. So the frequency, let's say A has like an odd frequency, and then B has an even frequency. So the thing is like, uh, we need to find some subarray here, subarray range here that when we okay, so let's see how I'm gonna explain this. Um, okay, so that the idea is like to find the subarray some frequency of this part, we need to take this part and subtract this part. So, oh, I don't want to change the color. Okay, there you go. Let me put choose this one. Oh my God, let's keep changing the. Okay, there you go. Okay, let's say this one will have frequency of some previous A minus frequency of some previous B, right? So the idea here is like, what would be the subarray sum of this part? It's going to be the frequency of A minus frequency of B. This whole thing, uh, let's see, this whole thing minus this part, right? Minus this part. So that's the answer for this part. But oh, let me put this in parentheses as well. Oh my gosh, dude. I can click here. There you go. Okay, so in order to maximize this thing, because we want the maximum difference between the odd and the even frequency, we want to make this part as large as we can, and we want to make this part as small as we can, right? So pretty much we're gonna keep track of the best frequency difference that we saw in the past. But the thing here is like the best frequency difference that we saw in the past, it's actually the minimum, right? Yeah, it's actually the minimum. So we keep track of the minimum difference that we saw in the past. So when we have add an occurring frequency, we can just get that minus that, and then we have the maximum value of this subarray. But the thing is like, oh, let's what if the best answer is the whole array, right? Then we just initialize both, but begin with 0, and then we will do like frequency of A minus frequency of B minus 0 and 0. So that will count for the whole array. So pretty much this is like length. The length of this thing is like n plus 1. Okay. So this is like the prefix array. But another thing that we have to consider in this case, like um, this calculation right here, we can't just deal with any range, right? Because we're pretty much doing frequency of A minus frequency of previous A, and then minus frequency of B minus frequency of previous B, right? So let's say we have a frequency of 3 for A, and then we have a frequency of 2 for B. And let me make it like this. Some larger element, put 2, 6 frequency for A, and then oh, I need odd. Oops. 7 frequency of A, and then let's have 3, 4 frequency for B. Let's say we have 7 A's and 4 B's. Let's say the minimum prev A in the past that we saw, let's say it was uh 3, for example, right? Let's say this. And then the previous B that we saw, the minimum one was, let's say, 2. Okay. When we take this difference of frequency between 3 and 7, we're actually going to get a frequency of 4, which is even. And it's not what we want, right? Because we want the odd frequency and then minus the even frequency. So we couldn't have a frequency, an odd frequency, but then in the past, the minimum that we saw in the past is actually an odd. This is a pretty interesting thing. So if you get an odd number and then subtract another odd number, you will get an even number, right? Which is not what we want. So in this case, we actually want to get the minimum frequency that we saw in the past that's actually even. So in this case, let's say the minimum that we saw that was even, it was like 4. So 7 minus 4, that's equal to 3. That's a valid frequency because we want odd in this case. Now for B, let's say instead of 2, the minimum frequency was 1. So we have an even frequency and we subtracting an odd frequency, and this gives us odd, which is not what we want, right? So we need actually an even because even minus even will always be even. So in this case, what we want is that we want the minimum value that we saw in the past that is also even. So let's say in this case we found 2. So 4 minus 2, that's equal to 2, which is even. This is equal to 2. And then 3 minus 2, this is equal to 1. So that's the range of this part. So the idea here is like on the right side, if we have an odd frequency, we want to get the minimum even frequency that we saw in the past. So the rightmost part of this yellow part. But if we, oh, actually, yeah, yeah. But for B, if we have an even, we still want an even. Let's say let's switch now. Let's say we have even in this part. So the right side frequency of A is even. We actually want to find an odd minimum frequency in the past, so we can subtract and still get odd, right? So let's say we have an even. If we subtract an odd number, we're gonna get. Oh, sorry. Yeah, yeah. If we have an even frequency and we subtract an odd, we're gonna get odd. And if you have an odd frequency and we subtract an even, you're always gonna get odd. So our goal here is always find a difference from the current frequency A and the past minimum frequency of A, that the difference will still be odd. And this happens when we always try to find the opposite on the past. And then for the even, we just want to match. So if B is even, we also want to find a minimum even in the past. If B is odd, we also want to we want to find the minimum odd one in the past. And that's pretty much the idea. So we pretty much make it tracking every single odd even matching combination. So we can always go back to those. We're gonna have like a list, 4 elements. So odd, odd. Well, let me do even first. So even, even, even. Let's say even. Oh my God, I can't write. So even is 0, and then odd is 1. So what we're doing here is, so we have even, odd, odd, even, odd, odd. This is like all the possible combination we're gonna have. And then in on each index, we're gonna track the minimum frequency we found in the past. So let's say for 0, 0, let's say we are at this point on the rightmost side of the red. The 0, 0 the 0 index of this array will contain the minimum difference that we found in the past. Well, okay, so index 0 is going to be the minimum difference between the frequency of A and the frequency of B that we found in the past that has A as even and B as even. And it's going to repeat for the rest. Okay, how are we going to calculate this? We're going to start with a window of 4, which is in this case, but we're going to be like a window size of K. And we're going to keep moving the window forward, checking if the range of K, the current range of K is the best one that we have. No, actually, we're gonna keep moving k. So we're gonna have like a right pointer and a left pointer, and then we're gonna for each right pointer, we want to find the best subarray sum that we found up to that point. And we're gonna do that by taking the difference between what we have right now, which is the left side, and then we match with the array that we tracking here for the all the combinations. So the frequency that we currently have on the right pointer minus this part of the equation, and this part of the equation we're gonna find based on this tracking right here. Okay, that's another part. And then let's see. As we move the window to the right, we also want to update with the left pointer, right? The left pointer is what we want to track all the previous element that we saw. So pretty much updating this array right here. Okay, this is another part. And then let's see. There's also another thing here. Okay, this is another part that I got really confused too, which is like, let's say we have this subsequence. So one, two, oh, actually, one, one, two, two, one, one. Let's do one, one again. Okay. So let's say we have using like a prefix sum approach. We'll make this a little more spaced. This is good. Oops, there you go. Okay. So let's say also we're gonna keep the count. Let's say we're gonna keep the count of ones and two in this case. So let's do prefix sum. So let's say ones and then twos. So in this case, we're gonna have 0, 1, right? Because we have 1, 1 at this point. We have another 1, so we update 2. This is 0. We finally found oh, this is ugly 0 here. Okay, let me use this small. There you go. This is better. Okay, 2. We have 0. Now we find our first 2, so we're gonna increment the count, but we didn't find any 1s, so we're still gonna keep 2. And then this one gonna be 2, 2. And then we're just gonna increase 1, so 3, 4, 5, 6, and here's still 0. Oh, not 0, keep 2. So what is happening is like, let's say at this point, oops, at this point, this index is saying that we, up until this part, from 0 up to this part, we found 2 2s and 2 1s, which is correct, right? Now, let's say we are at this this point right here, this server rate. So let me make it clear, this part. Let's say we're at this part. But we want to calculate the subarray sum of this part, right? So what we're going to do, we're going to grab the current right pointer that we have, the frequency, and then we're going to subtract not this part, but this part, one before. So this is what I'm doing here, pretty much. In this case, 2 minus 2 is equal to 0. What does that mean? That means that at this point, up to this point, we found 2 zeros in the past, not necessarily like within this range. It could be like before this range. And on the previous subarray, we also have two twos before that. So when we take this difference for the even, uh, let's see, yeah, when we take this even for the even for the even frequency, this tells us that within the range that we're currently at, we don't have any twos because we found, okay, so up to this part, oh my God, it's not good. So up until this part, we found two twos, two twos, And then in here, we also found two twos in the past. So that means that the two twos that we have, it's actually here, up until here, right? And not within this range. Because if we have two twos up until here, and we also have two twos up to here, so the two has to be in this range, right? So we don't have anything here. So this tells us that this is an invalid window because we need to have at least one odd frequency and one even frequency. But the interesting thing is that this is not going to happen for the odd frequency because for the odd frequency, we actually want to flip, right? So if we add a odd frequency, we want to get the minimum even frequency, right? And if we're gonna change a number from even to odd, there has to be some element in the middle. So that's the main idea here. Let's see. hmm So let's grab like a valid window right here. Let's count the odd. So let's say we have three, right? The number of ones in here is five up to this case, and the number of ones in here is actually two. So wait. Yeah, we have odd, so we have to find an even frequency that happens in the past. So for an even number to get to an odd, this difference has to have an element in the middle. So let's say up to this point we have three elements, and then up to this point, okay, so let's say we have three elements of frequency. If we want to get an even frequency that happened in the past, let's say we have two. For an odd number to get to an even number, we have to have an element here in the middle, right? Because a number cannot be even and odd at the same time. So if we have an odd frequency, we actually want to subtract the minimum even frequency that happened in the past. But if we're going from odd to even, there has to be a number in the middle that was made possible to go from even to odd. That's what I mean. But this is not the case with even because for an even number, if for an even frequency, we actually want to get, let's say we have an okay, so let's say we have an even frequency. So for the first part, we want to find an odd. So we're trying to maximum, let's say A is the first frequency, B is the second frequency. We want to find A to be odd and then B to be even. And we're going to maximize this difference. That's the answer. So for the odd part, let's say odd is, well, the current frequency is 3. We want to target an odd frequency, right? So to subtract 3 so subtract from 3 to get an odd element, we need an even element, right? So let's say in this case 2. So to go from 3 to 2, we have to have at least one element in the middle. But for B, we want an even frequency. So let's say we have an odd, we want an odd. Oh, let's say, okay, so let's say for the second part, for B. Let's say we have an odd frequency. We want to find an odd frequency that happened in the past. So we can do like odd minus odd is equal to even. So 3 minus 1 to your odd numbers, that's going to be even. That's what we're targeting. The problem here is that 3 is odd, and we want to find an element in the past that's also odd. But 3 is also odd. So that difference can be 0. And if the difference is 0, that means that we don't have any element in this subarray that we couldn't add. So it's kind of hard to explain this, but the idea here is like when we're counting the frequencies difference, if the frequency of the B that we're taking the difference is 0, that means that we don't have a valid window. That's pretty much it. Okay, how are we gonna track? Now, this is like the basic idea. How are we gonna track? Well, this part we're just gonna like there track this array right here. So we're gonna for to map the frequency to this array. So let's say like three. Let's say we have one. Oops, 1 and 3. This is odd, odd. This is frequency, right? Frequency match is odd, odd. So we're gonna have 0, 1, 1, and we have to map this to this part. So it's pretty much a binary mapping. So 1, 1 is actually 3 in binary. So 0, 1, 2, 3 to the last one. This is 2. No, this is 2. Right. Swap them. There you go. So 0, this is 1 in binary, this is 2 in binary, this is 3 in binary. So for each frequency, we're gonna have like helper functions to help us to get from a pair of frequencies to this array. So if the first element is odd, so in binary we have, let's say we have 0, 1. This is pretty much 2 to the power of 1. Oh, sorry, this is 0 to the power of 1, and then this is 2 to the power of 0. So if the first element to the left is 1, then we add 2, otherwise we add 0. If the second element is 1, we add 1, otherwise we add 0. So we're going to have either 0, 1, so 0, 0, that's 0, 1, 0, 0, 1, 1, 1. Okay. There's like a bitwise way to do this, but I just found this one's easier to understand. Okay, so now when we go back to this example, we kind of like just did the frequency matching between 1 and 2. Like what if we have like 3 and 4 here, right? Because and 0, because on the specification right here, it says that we can have numbers from 0 to 4. This is like a constant amount of numbers, which is 5. So we can just do every single matching. So we're gonna do 1, 2 first. So 0, 1 actually. So 0, 1, 0, 2, 0, 3, 0, 4. And then 1, 0, 1, 2, 1, 3, 1, 4, and so on and so forth. So it's pretty much a gonna we're gonna make this calculation for every possible combination of 0, 1, 2, 3, and 4s. Okay. And then at the end, we're just gonna grab the best. Okay. Let's see. I doubt someone will understand my explanation in this case, but it's more for me to have a track why I code this thing. Okay. So we need, first of all, let's do n is equal to the length of s to make it easier. So first of all, we need two helper functions, right? So the first one is going to map two frequencies to the array. Let's say we have odd even. Odd even is going to be 1, 0. 0 is going to map to index 2. So we're going to do, we'll call this like parity. So I'm going to do def parity calc. I'm going to take two frequencies, A and B, and this is going to return an index. So the idea here is like, let's say we have, blah, blah, blah. Let's say example, right? Example, let's say we have 3, A is equal to 3. This is odd, and then B is equal to 2. This is even. Oops, see if I can type. Let me fix my keyboard. This is even. So this will return what? Odd even, so this is 1, 0. Because this returns 1, 0. Because 1 is odd. That's right here. 1 is odd, 0 is even in return. Okay, so if we have A is equal to 3, B is equal to 2, that will map to 1, 0. Okay, so out is equal to 0 if A mod 2 is equal to 0. That means that A is odd. Oh, A is even. Let's see. One, that's one, that's one. So A is always going to be the first element, B is always going to be the second element. So if A if A is even, that means that we're going to have a 0 to the left. So we don't add anything. So if A is the mod is equal to 1 actually, that means that it's odd. Then I'm gonna add 2. Okay. Mm, okay. If B mod 2 is equal to 1, that means that the first bit is gonna be 1, because that represents odd. And then let's see. So if the first element is 1, we're gonna add out plus equals 1. So that's okay. Just go back to my notes real quick. Yeah, okay, so it's 0 to the it's not 0 to the power. Sorry, I knew I had like some mistake right here. That didn't make any sense. Oops. This is actually 2 to the power of 0. Oh, let's say okay, so let's say we have 1 1 in binary. This is actually 2 to the power of 0, and this is 1, so this is 2 to the power of 1. If we have 0 1, that's going to be 2 to the power of 0. And then 0, so this is 2 to the power of 0, yeah. But if we have 1 0, this is to the power of 0 to the power of. Oh my god, I'm kind of like. I know this is. I'm confused by binary. Okay, so this is 0. So this is. Okay, so this is 0. Oops. I haven't got this one again. This. Say. Okay. So we have 2 to the power of 0, to the power of 1, to the power of 2, blah, blah, blah. So if we have 0, 1, this is 2 to the power of 0, and this is nothing, so we don't count this part. Now if we have 1, 0, we don't count this part. Yeah, this is 2 to the power of 1. Let's say we have 1, 1, 1, this is 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2. And then if we have 1, 1, 0, this is actually nothing because we don't count. It's actually 0. And then 2 to the power of 1, 2 to the power of 2. Yep, okay. Let's go back here. Okay, so this is right. If A is odd, we add 2. If B is odd, we add 2. So if both A and B is even, that should return. If A is even and B is even, that should return 0 0, which maps to 0, and then that's out. But then another thing that we kind of have to take into consideration is like we always want to maximize the odd minus even frequency. So for the even part, we can just if the even for B, right? So if B is even, we could just subtract even to keep it even. If B is odd, we could just subtract odd, another odd number that will keep it odd. That will keep it even actually. But for the odd number, if A is even, we want to subtract. If A is even, we want to subtract an odd value that happened in the past that's minimum. So the idea here, using this array here, is that if A is odd, let's say we have um let's see for A, let's see. Let's say we have the combination odd even for A and for B. To make this found the max solar array sum for this part, we will have to keep B odd because we want B the frequency of B to be odd and to be even and the frequency of A to be even. Oh my gosh. We want the frequency of A to be odd and the frequency of B to be even. So for B, if B is odd, we can just subtract another odd number to make it even. So B will still be 1. But for the A, we want an odd frequency. And if A is even, then we need to find an odd frequency that happened in the past that when we subtract that for the current frequency, it will make it odd. So if A is even, we need to find an odd number A in the past, because then even minus odd, that's odd. This is the mapping. So we basically flip this part, this bit, from 0 to 1, and then find the minimum value in this array. So we also need a function that does the flipping. So def flip, ready, all, so AB, that's an integer. So it's pretty much the same idea in here, but we want to flip A, right? So this is pretty much how you do, right? So plus 1. So if we do this plus 1, if A is even, so let's say we have 2, if we add 1, it's going to be 3, which is odd. That flipped. If A is 3, which is odd, you add 1, it's going to be 4. 4 is even, you flipped. Okay. Let's see. Okay, now we need to do the calculations, right? Okay, so we're going to have a def calc AB, the current frequency that we have. This will return an integer as well. That's this. And then this is the main function pretty much, the calc. This we're going to use to calculate the maximum difference frequency between two elements. So let's say we have 1 and 2 first, we're going to calculate for that. And then after, we're going to calculate for 1, 3, 1, 4, so on and so forth. And then what would be the answer in this case? So for A and so it's going to be from 0 to 4. So 0, 1, 2, 3, 4. For B and 0, 1, 2, 3, 4. We don't want to do like matching one with one, right? Because that doesn't make any sense. So let's say we have two ones and two ones, like that's not a valid window. So if A is not equal to B, then we can do the calculation. Gonna have like a base here. It's gonna be also one infinity up here. So infinity and the power of 10. Oh my God, what happened here? Uh, wait, what happened? Oh my God, what happened? Okay, I don't know what happened. Okay, so we have infinity, and then best will be negative infinity, right? And then if A is equal to B, not equal to B, best is equal to the max of best, and this calc AB. And then at the end, we just return best. Okay. All right. Uh, let's see. Now it's time to calculate. First of all, as we saw here, we need this prefix sum for both A and B, so we always need the frequency of A and B. So let's make like a dry run to calculate the prefixes. So calculate prefix. So we have prefix sum of A, and we also have prefix of B. And what's going to be is out is going to be 0 times n. But remember here that we want to take into consideration the case where the whole array is the best option, right? So to take that into consideration, let's say we have the whole array. How are we going to find that this whole array, let's say we reached the end, how are we going to find that from the end, the best option is the whole thing? Because when we try to subtract to find the prefix sum using Cadet's algorithm, we're going to go, we don't want to go to the first element of the subgroup. We're going to go one before, right? It's pretty much this idea right here. So I think I had somewhere else. Okay, so anyway, so it's pretty much here. So when we are here, we don't want to subtract here, right? We actually want to go here minus one. We want to go here. But in this case, if the whole thing is the answer, we actually want to go out of bounds. So we want here this zero right here. We want to reach here to subtract zero. So if we have the whole array as a subarray, and this is the best answer, it's pretty much the frequency of this part, the red part, minus zero. That's why we map to here. So we want to we're kind of like want to add an extra element at the beginning to count for this scenario. So this is going to be instead of n, it's going to be n plus one. Same for here, n plus one. Okay, and then let's calculate the server right now. So for range of A, oops, range of n, actually going to go one because the first element we want to be zero, so 1, 2, n plus one. Okay, if s index I is equal to A, okay, so let's calculate A and then we calculate B. So for A, if s index I is equal to A, then the prefix sum A index I, we're gonna add one element, right? So it's gonna be plus equals prefix sum A index I minus one plus one. But since it's equal to A, B is gonna maintain the same. So B is equal to prefix index B, but no plus one. If S index I is equal to B, then the prefix sum x B index I plus equals prefix sum x B I minus one plus one, but then A doesn't change, right? So we replace this with A, remove this one, replace with A, and remove this plus one. So this is actually going to be an aleph, right? Now we can remember that we are always doing the frequency calculation for two elements. So let's say we have 0, 1, 2, 3, 4. We start with 0, 1, 0, 2, 0, 3. So it can be that as we calculate for two elements, we have a new element that we don't know. It's not that we don't know, it's that we're not calculating at that specific moment. That's going to be this else part. So let's say we're calculating the frequency in this case. Let's say we have like a 4 in this case. We don't want to count this 4 because we only calculate 1 and 2. So we're just going to repeat the frequency to the next. So pretty much this part. Yep. Okay. Now here, after this loop, we have um, Just from right here. We have the prefix sum arrays, and now we need the two binary mapping arrays, right? That we have right here. That's gonna map to the indices, and we first want an array to track the minimum frequency difference that we found in the past, but we also want to track the index that this frequency happened, because for the even part, if we have a 2 in here, and then the previous subarray, we had also a 2 frequency. So that means that we don't have we kind of like need the indices to make sure for the even frequency that the subarray is valid. So uh, so main val is gonna be this. We also want to do the minimum, so we're gonna do infinity times 4, right? Because we had 0, 0, 0, 1, 1, 0, 1, 1. We also gonna grab the index, so index 0 this. Oops, not here. Val index. Okay. Mm-hmm. Okay. Okay, that's enough. Now we have the mapping. It's time to go over and calculate. So left is equal to left, right, the pointers, 0, and then k. Okay, let's say we have a k is equal to, let's say we have 1, 2, 3, 4, 1, 1, 1, 2, 3, 1, 1, 0, 0 to 4. So let's say k is equal to 3. We want to grab the first three elements. So we start at 0, and we're going to all the way to here, 0, 1, 2. But k is equal to 3 here. But we actually want to take into consideration that on the prefix sum array, that's we have shifted the indexes by 1. The offset is 1 because the first element is 0, 0, which is uh, this thing right here, to consider the whole array as a subsum possibility. So I think we should do is we actually want left to be equal to 1 and then k is equal to 3. So then on the prefix sum, that's going to match perfectly. Okay. So while r is less than n plus 1, right? Okay. First, gonna grab the current frequency that we have, which is this case is this part, uh, frequency A minus frequency B. So current frequency A is equal to the prefix sum of A and x right, and then B, it's pretty much the same thing, but B, and then let's see. We first want to check if we found an element in the past in this mean val tracking. Oh, pretty much this tracks the minimum frequency different we saw in the past. And then this one tracks the the index that the above happened. All right. So if it's infinity, another thing I just remembered. At index 0, like here, we actually have 0, 0 frequency, right? So before we start, like before the beginning of the array, we have 0 frequencies of 1, of 2, of everything, right? We don't have anything. So that's kind of like it's kind of like a base case. So at 0, 0, which is even, even, 0 is even, we have 0. So that's why, uh, oops, main val index 0 is actually is equal to 0. And then this one as well. Okay, all right. Okay, now we calculate the frequency and we're gonna check if we found a good frequency in the past that we can subtract and get the current best. And then this current frequency that happened in the past could be either 0, which that means that the whole thing is the best option, or you occur like something in the middle. So let's see. If the main val index, so in this case we want to flip the parity, right? Because if A is odd, we want to subtract it even, and if B is even, we just want to keep even. So flip parity calc. It's calculation, right? So calc, and then here as well, it's calc. Okay, calc, current frequency A, current frequency B. If this is not equal to infinity, that means that we found a good matching before, right? And then, oh, also on this calc, we have a best, which is equal to negative infinity. Okay, so this is the best for the current calculation we're doing. Let's say 0, 1 are the current candidates. So let's see. Okay, so if we found a good frequency to pass, we need to check if that window is valid. And for it to be valid, we have to check if the currency of B that we couldn't have minus the currency of B on that specific pass occurrence is not equal to 0. So that means that we have at least one element in the middle. So Prev index that this best frequency occurred is equal to main val index of what index? Mm, okay, now I'm thinking a little bit. So we want to make sure. Okay, so I'm currently tackling this case right here. So the case where this is the range, right? So this is the current position, the frequency that we have. This is the right side. We want the left side -1. Okay, 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 so previous index, B frequency is equal to actually, no, it's not this one. Sorry. So, okay, so B frequency is going to be, yeah, so mean val index at the same. So, oops, here, let me create this window a little bit. We don't need all that. Let me do left. Let me do first, the third. There you go. Then right, last. Oops. The third. There you go. Okay. Okay. So the previous index that happened was mean value and the same flick parity calculation. Now, if we need to check if it's a valid window, so we have at least one odd and one even. Okay, so we don't have to worry about the odd because we flipped the parity, so we need to check the even. So if prefix sum b index prev index frequency. Mm, actually myself first, right? So if prefix b index right minus this is not equal to 0, that means that a valid we have a valid window. Okay. Okay. Okay, so if we have a valid window, now we're gonna try to what? Update the best. So best current best is equal to current frequency of A minus current frequency of B. Prev best is equal to we actually can do right here, right? Current best, prev best is equal to this thing right here. Oops. Oh my gosh, there we go. Prev best. Okay. So if we have our window best, you're gonna be the max of best uh, and current minus prev best. Okay. If it's not infinity, if that means that we found a good mean in the past, and then if the frequency of beam is good, then we update the max to be the best of the current max and the current difference that we have, which is current best minus the previous. Okay, that sounds about right. Okay, and then at the end, we're gonna update the 2 pointer, so right plus equals 1. And then, as I said before, we need to update the left. So let's see. Update mean vals with left pointer. So as we move the window to the right, the left pointer is responsible for always updating the best frequency we saw so far. The minimum best frequency difference that we found so far. There you go. Okay, so we're gonna do a left plus equals 1 again, but before we're gonna update. So prev left frequency is gonna be the prefix sum of A index left minus prefix sum B. I'm actually gonna do prev left. What did I call before? Just not actually what I'm okay. So prev left frequency A is equal to presum A. It's left. We also want B, and then I'm gonna map this to the main stuff. So min is equal to main val index. So in this case, we don't want to switch the parity, right? Because we pretty much updating using the left side. So we want to put in this array the best. We're going to update in this array the frequency that we currently found, pretty much. So we don't want to flip it. So parity calc preval A, preval B, and then if prev min, oops, if prev left frequency difference is equal to prev A minus preval B, if preval frequency if is greater, oh, we have one small, right? Then prev min, then we want to update the table mapping. So prev min, oopsies, so min val, array calc, prev val frequency A, prev val frequency B, that's equal to A, that's equal to prev left frequency diff. I'll also update the index, so min val index inside this whole thing. That's equal to left. Okay. Yep. Yep. That sounds about right. Then at the end, we just return best. Okay. I think this should be it. Um, might be missing something, so we'll see how this goes. Okay. Let's get some 1, 2, 2, 3, 3, 4. I'm not sure what this. Okay, let's try 1, 2, 2, 3, 3, 4. The answer should be -1. Let's see if we have -1 here. Is that daily? I think so. Oof. A range. Oh, because we're doing the offset. We're doing the offset in the prefix sum, but we are not doing the offset when matching the actual string, right? So for the string, we have like 1, 1, 2, 2, 3, 3, 3, blah, 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 and that's 0 indexed. But for the prefix sums, since we added a 0 at the beginning, this is now 1 indexed. So this actually should be I minus 1, I minus 1. Okay, yep, sounds good here. Let's see. 1, 1, 2, 2, 2, 1, 1, and then k is equal to 3, 1, 1, 2, 2, 2, 1, 1. Okay, this should be 1. Looks good. Let's see. Make this real quick. See what we got. Hey. Good. Oof. Let's see what did I miss here. Output was -1, but should be 1. Might have some, might be missing maybe some indexing stuff. If I'm doing this is right. So return -1. Uh, prefix. Would I start at 1 in here? Oh, it's not 1. Anyone? No, I'm skipping the first left pointer. Yeah. When we move the window to the right, this left start at one. I'm not taking consideration the index zero of the prefix. Is that right? So I'm not sure if that makes sense. Let's see. I think I added this. Oh, okay. Okay, now I got. Okay, still got -1. Let's see. So no, this is right. This is wrong. No, this should be one. This should be one. Pretty sure that should be one. Let's see. Where's this? It's -1, but should be one. Yeah, I want to make sure the parity calculation is right. So, right. So we have A, no, 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 A, we have B, and then we have, if that's right. Okay, still one, that's 0, 1, that's right. 1, 3, that's 1, 1, that's 3. 0, 1, that's 1. Does that mean 1, 0 here? 1, 0, that's 2. Okay, that's right. So if this is right, then the flipping should be right as well. Because we're just flipping A. So the prefix sum should be right too. That should be right. Back the minimum difference. Grab the current frequency on the right. The current mass is this frequency of the prefix sum. And then prev as flip the parity calculation for that part. Okay. If prev best is not equal to infinity, that means that we found an answer in the past. So prev index. Oh, we need to check the frequency to make sure we have a valid window. Mm, there you go. Oh, no, that's right. That's right. We should still flip this mean valid index, and then if the prefix sum minus prefix sum b index prev index b frequency is not equal to 0, that means that it's good. That's equal to max current best and the previous best. And then we update one. We need to update the intervals. So pref left A, prefix sum A, pref left B is equal to prefix sum B. Pref left difference is going to be that one. Pref min, the index on the left. Okay, AB, I calculation without flipping. If the pref frequency is less than the pref min that we found, oh, this is not index, right? This is min val. If the pref difference is equal to the pref min, then we're going to so we go to the left, and this part should be like 1. There you go. Oof. Okay, because we have two different array, right? One for the previous minimum frequency difference that we saw in the past and the index that occurred. And I was using the wrong one. I wanted the frequency, but I was getting the index. So let's see. Mm. Okay, pass. It's given us submit. Okay, so yeah, that took me a while to understand. I had to like kind of like go through Kdane's algorithm again. There's this like another question called max subarray sum, which is like pretty much the base of Kdane's algorithm. So I went through that one first, and then I tried to do the bitwise thing. Uh, I was just not getting it. So this kind of like a dumber way of doing it, but works. And apparently it doesn't affect the runtime areas as much. So whatever. So yeah, that was a really hard question. I tried like the day of the question, like in June 11th. I tried using a recursive approach, and then of course I got time limit. I got timed out, and then I tried to do like some sort of a caching, still didn't work. And so I tried to go through the cadence algorithm approach. Wasn't able to extend, and then yesterday I was able to finally understand the theory of this. Tried to implement it by myself, worked, and today recording this video. So yeah, that's pretty much it. I'll do the daily question after this and post as well. Yeah, that's pretty much it. See you guys later.